Okay, so let's actually start reviewing pull request, and let's actually start from the bottom, right? So from the oldest one. So here we have ASM function, right? So, and this is an inline assembly. You know what? I feel like I need to change the title according to what I'm reviewing right now, right? I think it sounds like a cool idea. So let's actually set title inline assembly. Right, so because that's basically what we're reviewing right now. When I switch to the next pull request, we're going to change the title again, so to be on like up to date with what we're doing currently. So here's an idea that I suggested how to implement. Null nominal implemented it, and it's implemented as basically having a function underscore underscore asm underscore underscore, which basically is a variadic function, and it collects an a list of string literals, right? And it emits intermediate representation instruction with that specific list of string literals. So then when this specific intermediate representation is passed to one of the code generators, they then pass these strings to their corresponding assemblies, so you can actually have inline assembly depending on different targets that you currently compiling to. So it's kind of a, I'm kind of split on this specific feature because I don't see any use for it right now, at least. And what's interesting is that depending on how you implement your target, implementing that specific new instruction, implemented OP ASM instruction, might be super easy or super fucking difficult. So for example, in case of a FASM x86-64 Linux or FASM x86-64 Windows, we've got Windows support recently, believe it or not, right? So in fact, we can even check this kind of stuff, right? So what is the list of targets? I should probably rebuild this entire thing just in case, right? So just to have a fresh compiler. Compiling the compiler, right? So this is the list of all of the supported targets, right? So we have FASM Windows, FASM Linux, GAS, Arch, right? Arch64, which is ARM, and then UXCN, right? In case of these three, it is super easy to implement this instruction. In case of UXN, it is difficult because it doesn't have any underlying assembly that we call to. So in case of these targets, we just generate text representation of the corresponding assemblies that we have in here, FASM or GAS, and then we just give that text to one of these assemblies. So embedding things in that assembly is very difficult. In case of UXN, Deniska, who implemented this target, actually just has his own assembly, right? So there is no underlying assembly to pass information to. And both of these approaches, having an underlying assembly and not having an underlying assembly, has its own pros and cons, right? So in case of having an underlying assembly, it makes it easier to implement op ASM. But in case of UXN, when assembly is literally built into the compiler, it reduces the amount of the moving parts. For example, if you don't have neither of the assemblies installed of your system, compilation for this target is not going to work. UXN, on the other hand, it doesn't matter what you have on your machine, it always will work. It reduces the amount of moving parts, but it requires implementing, re-implementing the whole assembly if you want to have inline assembly. And I feel like currently we don't really have much use for this specific feature, right? And I have a feeling that maybe in the future, eventually we're going to remove it. But I want to accept it anyway. I want to accept it anyway and just let people play with this feature, right? And see, maybe somebody will find a use for it, right? So I'm going to let it, sit around, just see how people use it. And if nobody really uses it, we're probably going to remove it. So that's basically the plan for this feature. That's basically the plan for this feature, because I see that for UXN, it could be a little bit annoying to implement because you have to implement the entire assembly. Right, but for other targets, it's as easy as just passing this string to somebody and just forgetting about it. So it's kind of, I don't know. Okay, so let's actually fetch the latest, this specific pull request. So I don't even have null nominal in my remotes. I probably want to add them super quick. So it's going to be add this entire thing like so, and it actually gives me this entire thing. All right. So let's see what we have in here. Let's see what we have in here. First of all, by the way, it's we have merge conflicts because I've been merging some other pull requests and stuff like that. So this is something that we'll have to resolve first. So what is the branch that we're currently reviewing? We are reviewing, so it's just main. It's literally in the main. God damn it. Okay, sure. All right, so let me see. So this is Asm, right? So this is inline Asm. So if we take a look at all of that stuff, so what's the... Yeah, so it was diverged quite a bit. But I don't think it's going to be that big of a problem. Right, so first of all, we can just like, you know, run and test and run some tests, right? So just to see if everything's fine. Everything seems to be fine. Everything seems to be fine. Okay, so the thing is, I'm not particularly happy that this is just string on its own without any additional information on the location and stuff like that. I feel like for the implementers of the assembly, it would be kind of nice to know where each individual string literal is implemented. You know what I'm talking about? It would be kind of nice to have that. So let me actually see. So Asm, so here it is. Maybe it should have been something like this. Right, where loc is a location within the source code. We even have can take a look at Alexa. So it's defined in Alexa. It gives you the file path, the file where it is defined, the line number and line of set, and you can use this kind of stuff to report different errors and stuff like that. So I'm not sure, right? So it's probably needed for the custom assemblies for some of the targets. So if it's ever needed, I think they can implement it themselves, right? So right now it's not like really needed, so let's not implement that, but that would be nice, kind of. So here is the thing. So this thing is implemented as a function. This thing is implemented as a function, and as a consequence, you have to extern it. Right, so that's a thing. That's a kind of an annoying thing. And then we are compiling it. We're compiling it as a primary expression, even though this thing is not really an expression, right? So expression implies that you can embed that thing into different places. That's what it implies. Is that a good thing to imply? I'm not even sure. Should we allow, you know, embedding it into different things? I'm honestly not sure. Is that a good idea? All right, so let me take a look at that. So it's some sort of a test, right? So this is the tests. So here is the Asm. So what's the meaning of something like this? Is it possible, for example, in C to do something like this? Right, what do you guys think? So who worked with, for example, GCC? There's could be expression of type void. There is no types in B, bro. Come on, there's no types in B. So does, for example, this kind of expression make sense in GCC? In C, it's a custom piece of syntax. It's a custom piece of syntax. Let me actually maybe experiment with that a little bit. So I'm going to create like main C. And I do remember that we had this kind of stuff in coroutines. We used inline assembly in coroutines. I'm not an expert in inline assembly, but I used it once because I know just assembly in general. Right. So this is basically how they do that. We can try to maybe copy paste this kind of thing in here. So let's actually do a little bit of a hello world. I just want to see how the compiler is going to react to. Just want to see. Right, so, and it's even highlighted. Look at that. It is even highlighted by my, you know, highlighter. So, which implies that this is probably a keyword. Right, so what if I do something like that? How the compiler is going to react, at least like the parser of the compiler. It's actually rather interesting. I'm not really sure what's going to happen. So what's it going to say? All right. Oh, expected and express. It's not even considered an expression. Damn, browskis. You can do things like register Well, that's kind of bizarre. So this is a Rax assembly. No, this is kind of a different syntax. I feel like this is a different kind of syntax. What I'm trying to say is that it feels like actually that asm is literally a keyword, which prevents me from doing something like this, I'm sure. It's not even an identifier. It is not even an identifier. It is a keyword. They just made it asm keyword, and they have a special way of handling it in expressions and stuff like that. By the way, we can do the same. I recently actually wrote custom Lexa, right? So we got rid of STBC Lexa and stuff like that. We rewrote it from scratch. Well, not really rewrote it, we wrote our own from scratch. And one of the things I actually introduced recently, I introduced notion of keywords into the Lexa. So now, where are they? I don't see the keywords. I don't have a keyword. Did I not? It's in the latest changes, right. So it's in the latest changes. But so essentially now we are not first parsing identifiers and then look at the value of identifiers and see if it's a keyword or not. We delegated that task to the Lexa itself. Now Lexa, if it sees a keyword, it will emit a keyword, not an identifier, and your parser, which expects identifier as a name of a function or a name of a name of a variable, it's going to error out because it's not an identifier, it's a keyword, right? And I think this is the right way to do that, and C compiler, as you can see, does that as well, right? So they made that a keyword. So what I'm trying to say is that I think we need to make this thing a keyword. Right, I think it is fair to make this thing a keyword. So, but we can't really do it right now since, right, we don't have the latest changes, right? Because it was introduced in the latest changes, we need to merge all that stuff. So let's actually merge with the main branch. All right, so what do we have in here? Oh, it actually merged without any problems, right? So then I can just push that into your main and it will resolve the conflicts. Why GitHub was saying that there are some conflicts? This is bizarre. Wait a freaking second. If it just merged. So how GitHub identifies whether there are conflicts or not conflicts is just like, did it automatically resolve the conflicts? I'm not kind of sure. It's kind of sus. Don't you guys think? This is kind of sus. But anyways, so I don't complain, by the way, don't complain. So I don't have to go through all of that stuff. Ninja rebase, I'm not really sure what that means. So anyways, so we're gonna try to do that. So here's the test and stuff like that. Okay, that's pretty cool. And by the way, making that a keyword will actually make it so we don't have to extern it, right? So it will simplify a lot of things. So I'm gonna go into the Lexa and let's take a look at what kind of keywords. There we go. Here are the keywords, and I can literally just, you know, do asm __, and we have to introduce a new kind of keyword asm in here. So let me find the enum tokens, and here are the keywords, and I'm going to call it asm. So here is the asm keyword. So let's try to build this entire thing and see what's going to happen in here. Okay, so when we do the output, all right, so this is specifically for reporting errors, right? So display tokens, it takes a token and returns a string, and this is needed for diagnostics. For example, to say, all right, so expected identifier, but got something else. So this is where it is usually used for, right? So just to give you a context. So here is the assembler, right? So the assembler, and we say it's a assembler keyword, right? So this is what we need to put in here. And it compiles. Now we have an assembler keyword, and what's funny is that that probably breaks the test that you actually wrote in here, right? So because now this is not going to be parsed as an identifier, right? So where is that? I don't see that. Yeah, so you're looking for, so if it's an operand, what am I looking at? Excuse me. Yeah. I see what you're trying to do. So in trying to parse this thing, you parse an ID, and this is where the function calls are parsed. If it's identified as a function call because it's an open parent after a name, you check whether that name is asm, right? You check whether that name is asm, and then you just do your thing, All right, so that's very interesting. That's very interesting. So if I try to now build this entire thing, so asm b, expected identifier, but got keyword asm. Exactly. Oh, it's even in extern, which means, by the way, we have to get rid of extern. All right, so expected start of a primary expression, but got keyword asm. All right, so which means what we can do in here is actually, yeah, start a primary expression from the keyword asm. So primary expressions can start with oparent, with not, right, oparent means that it's a grouped expression, right, so open parent. With not, it means it starts with exclamation mark. Emacs, shut the fuck up, Emacs. Where is not? Here is it. That means it's something like this, right? So it starts with not. It can start with multiplication. That means it's a dereferencing. It can start with minus, with and so on and so forth. Plus, plus, minus, minus, doesn't really matter. So, and then it can start with ID. So now what we can introduce in here, we can actually say, okay, it starts with asm. So it starts with asm, and we can move this entire stuff, everything in here, to that specific place, right? So we can move it to that specific place. So now, which means we can completely get rid of all of that stuff because it's not a function call anymore. It's its own piece of syntax, as Spürtman said, right? So now we're literally doing the same thing as we do in C. Right, so it's a special kind of syntax. It's a primary expression that starts with the assembly keyword and it's parsed in a very specific way. Right, and we don't even have to look it up in a scope or anything, right? So it actually simplifies a lot of things in here. It does in fact simplify a lot of things. So asm only takes strings. So this is, I don't like this kind of things because it makes it difficult to change the keyword. What if I change the keyword itself? Right, what if I change? Now I have to multiply, now I have to modify several places. I already kind of have to modify several places, like for example in here. Right, so here is that, and also here's another place. But this kind of stuff adds a third place. So having, like, it would be ideal to have one place, but I mean, we're introducing a third one. So what I'm thinking is that what we have to do in here is do something like this. Nah, that's kind of difficult. But honestly, for each individual keyword, the way we parse keywords, right? We first parse keywords as an identifier, right? So we first see that it's an identifier, and then we look up, is this specific identifier one of the well-known keywords? And in that case, we change the class of that token. So which means that accidentally, we do have the name of the keyword in the token string, the place where we usually keep the name of an identifier. So this is rather convenient. So now we don't have to worry about modifying this place in case we modify the keyword. Right, so that's a little bit better in my opinion. That's a little bit better. Anyways, so now I can try to maybe recompile this entire thing. Right, so let's actually do recompilation. Recompiles, I'm going to try to compile this entire thing. So it only takes strings expected. Okay, so since we moved it in a separate place, after this entire thing, after an assembly, we should expect open parent. It was expected by the function call parse, right? So now what we have to do, we have to probably do something like, okay, so here is an assembly, and then we have to say get token get and expect collects, right? So, and this is exactly what we expect in here. We provide the lexa and we provide what we expect in here, and then we you know, basically unwrap it with error, right? So here's the asm. Then the next thing we expect is oparent, and we continue you know, parsing the thing. So now if I try to rebuild the whole thing just one more time, it seems to be compiling. Right, so, and now the example looks a little bit better, right? It doesn't even need extern anymore because this specific thing is a keyword, right? It is in fact a keyword. So pretty cool. And now it's not even possible to create a variable, for instance, with that specific name. it was possible before, but now you're gonna get something like this. Expected identifier, but got keyword ASM, right? So it automatically checks that you can't really do this kind of thing. So that's the advantage of having keywords in here. All right, so let me take a look at some of the subs. Thank you so much, World Emort, for Twitch Prime with the message inlining as emblements. Yes, that's exactly what we're doing right now. That's exactly what we're doing right now. All right, so we can even try to maybe run this entire inline assembly. All right, so we can do something like run. Well, I mean, we need to remove this kind of stuff. Right, and actually exit with 69. Right, so because here we just move 69 to racks, and then we, yeah, so then we clean up the stack and stuff like that, and then we just return. We could have actually called syscall or something, but I mean, that's totally fine. So my problem with this specific example is that it only works on a target of, let me see, x86-64 like Linux. So that's kind of the problem in here. This particular test is not universal. It works only here. Doesn't work here, doesn't work here, doesn't work here, doesn't work anywhere except that one specific target. And that's kind of annoying, right? So it's just like, how am I supposed to test that in other places? Right, what exactly am I, like, how exactly am I supposed to do that? So, yeah. So I'm not even sure. We probably need some sort of a mechanism that has like a list of target-specific tests. You know what I'm talking about? Like a list of target-specific tests. So it's kind of, I don't know. It would be good if ASM would allow you to write JS code for the JS target. That is true, but we removed JS target because it was too annoying to maintain. So, and it was a kind of a weird toy target, so it created more problems than actually, you know, needed, right? So we removed it. We're gonna have a WebAssembly target in the future instead. All right, so let's actually commit whatever we have right now. So introduce ASM keyword, and I'm gonna push that back into your repo. Right. So this is how I usually review my pull requests. Right. Instead of leaving comments, I usually modify the code to my liking and solving some problems, unless I encounter something like very significant. In that case, I usually pass it to you. But in majority of the cases, right, I find it easier to just fix things myself. You know what I'm talking about? It's the same situation as using LLMs for programming. Like, it's easier for me to literally just do it myself, like certain things, than explaining that in words, right? So, and then putting it as a message, so then waiting until you parse that message, internalize it. Maybe I actually explained it not really well, so, and there is some miscommunication. Like a lot of things, it's just like, it's easier to do it yourself, right? So, and I think this kind of like approach to reviewing is actually pretty effective in my opinion. It is pretty effective, so maybe have some back and forth, right? So I can modify things in here, and then I can ask you about some other things. You can modify some things, I can modify things again, and it's just like it's a back and forth until we get our pull request to the mergeable state. So I think it's kind of an interesting approach in my opinion, right? I don't see people doing that very often. What I see usually, especially in corporate environment, is just like everyone arguing in a pull request instead of writing code, right? So I think we should move code reviews towards writing more code than words. If you know what I mean. If you know what I mean. Anyway, so yeah, so this thing is still an expression, and I'm not 100% sure if I like that it is an expression, but maybe it gives you more, you know, more flexibility. But at the same time, C doesn't allow you to use ASM as an expression. So maybe we shouldn't do that as well. Hate corporate bullshit. Well, I also hate it. That's why I don't work in a corporate environment anymore. That's why I kind of abandoned all of that. Long time ago, actually. It's been a long time since I worked in a corporate environment. Is this using LLVM? No. We actually generate assembly directly. So we can even take a look at some maybe examples. Yeah, let's actually take a look at the rule 110 example. If I try to maybe execute, was it? Nah, it was, I think it was fifth one. Here it is. So here's the program, which is rule 110. And we compiled it and we ran it and it generated assembly directly. So this is the assembly that it generated. Right, so that's the assembly. And if we take a look at the code from which it was generated, the code looks like this. Right, so we just like analyze the code and we generate assembly without any LLVM. So in that case, we can say that it's just like we have our own backend. We have our own backend. So apparently you can do these kind of things. So in C, do I understand correctly? So this is a valid C. This is a valid C. So let's actually see if this is a valid C. No, not in C. But I mean, if it's not in C, right? So let me try to do something like that. So yeah, this is not an expression, right? So that's the thing. This is not an expression, and because of that, I have a feeling that we should not allow using ASM thingy as an expression as well. So I'm certain ASM is just a statement. Yeah. So I also feel so. Let's actually make it purely a statement, just in case. So will we be supporting more targets like x64, ARM, WASM? So just a second. We already support x86 64 Windows, x86 64 Linux, ARM 64 Linux, and also UXN. For those who doesn't know, UXN it's a small virtual machine. We support that as well. So that's the things we support. So we adding more. I don't know, like everyone wants to add more and more targets, and adding targets is actually adds like a lot of pressure on the developers. So I'm actually very carefully curating what kind of targets do we add. We do plan more targets, but if you want to add target, please discuss that with me first. Don't rush and implement the target and submit the pull request, because it will probably reject it. Again, adding a new target adds combinatorial explosion complexity kind of style. Right. So because now, like if you add a new opcode to the intermediate representation, we have to go and check each and individual target. So it's a combinatorial explosion. So we're being really careful with what we add. First, create an issue asking, may I add a certain target? Or what do you think about this target? And so on and so forth. We can discuss it there, right? So and if I approve explicitly, you can go ahead and try to implement that specific target, right? So it's very easy to add them, right? But then it's very difficult to maintain them. Right, again, I modify some instruction. Now I have to go to each and individual target and make sure that this instruction works there, or at least stop it. So like, you know, so it fails when you try to use that instruction for that specific target. Does it make sense? Right, so it's kind of difficult. It's very easy to add, very hard to maintain. So, and there's a reason we straight up deleted the JavaScript target, right? So there's a reason. So anyway, so let me take a look at these subs. Hey, you're here. Thank you so much for tier 1 with the message. Hey, Tsoding, I have 2 spare Raspberry Pis Model B2 laying around. I could send them to you if you find them useful. I have no address to send them to. Like, I don't know. I'm not giving my personal address where I live, but at the same time, I don't have any PO box, and how do you even send things to Russia? Like, I don't know. So like, thank you so much. I appreciate the gesture, but I have no place for you to send them to. So thank you so much. So Coding Butter, thank you so much for tier 1, and Verger Lurker, thank you so much for tier 1 as well. Thank you. CIA spotted, yeah. So CIA is trying to send me something. Walk to Novosibirsk. Well, I mean, it's kind of a dangerous city. So we have anal cheeks. So okay, so I wonder if I can find that. So Новосибирск, Новосибирск College, University. I have to be really careful with what I Google in here because I'm afraid I'm gonna actually. Yes, I found it. So I was afraid that maybe I'm gonna open something that is not TOS friendly. So just yeah. So there was recent news. I'm not sure how disgusting this is, but I'm gonna actually translate it to English. Right. In Novosibirsk, doctor removed the tick from the anus of the patient. So, and this is actually recent. This is relatively recent. So, if you want to visit Novosibirsk, keep in mind that we have very dangerous anal ticks in here. So, yeah, for anyone who wants to visit Novosibirsk, be careful. So, peak Russian floor. So have you ever played the Metro games? So some of them actually happen in Novosibirsk. Well, anyway. So let's actually continue. Let's make the ASM keyword a statement. Right, so right now it's a primary expression, but let's actually make it a statement. Most normal Russian. Right, so the funniest part, if you actually read the article, the patient didn't believe the doctors that was the problem, and he trying to sue them for defamation or something like that. So it's actually even funnier than you think. So bro can't even believe that it was an anal tick. So how can we make this a freaking meta flipping statement? So let me see chat. So there should be a function compile statement. Compile statements. There we go. So, and basically we have different statements in here, right? So things may start with a curly brace, which means it's a block, it's a grouped statement. It may start with extern and auto, right? So that means it's a local variable of some sort. It may start with if, that means it's an if expression, while loop, a return, goto. We support gotos, by the way. We do in fact support gotos. So, and now what we should do, we should just actually put, token ASM in there. In fact, I feel like I can just take this branch, this entire branch from the primary expression, right, so it actually comes from the primary expression, and put it into the function that parses statements. So now this is a statement, and it may not be used in a context of an expression. We can even test that, right? So here, yeah, here's the block. I moved it from one place to another one. Let me stash these changes, right? So I'm stashing these changes, and I'm going to try to run this entire thing. So tests ASM B. So it works, it returns 69. So now I can try to do some interesting stuff. For example, I may use it in a context of an expression. So extern printf. Printf. So this is something like s, and then I can close it like that. So now it is used as an expression. I may actually rebuild every time I run the compiler, right? And it works. And I'm not super happy with that because it's not really clear what the fuck that means, right? It's not really clear what the fuck that means. Now, I'm gonna unstash these changes and try to recompile. And it doesn't even fucking compile. So let's actually see what the fuck is going on because it tries to return autovar. So one of the advantages of making it a statement, one of the advantages is that you don't even have to return anything, right? So it's just a statement. It doesn't even return anything, right? So I can do something like that. And now one more time. And as you can see, expected start of a primary expression, but got keyword ASM. So you're trying to use this thing in the context of an expression, and you can't do that because the only place you can use this kind of thing is in the context of a statement. It can be only a statement, and this is exactly what I wanted to have in here, and that works. Right. So it has a bunch of warnings in here, so we're allocating some auto-vars. And by the way, we probably don't even need this auto-vars anymore. I remember null nominal asked, how do you call a function that doesn't return any value? If you make this thing as purely a statement, now you don't have to worry about functions returning values. So that's how you solve this kind of stuff very easily. So the code gets better and better and better, hopefully. Right, we'll see. So that seems to be working. That seems to be working. So let's do a committee. So maybe, oh, that's kind of weird. So it doesn't require semicolons. How the fuck did that happen? Because I forgot to require it. Right, so I have to explicitly say, Brovsky, you must have a semicolon. Like this. Spend 3 hours debugging and it will... Sorry. It's my favorite joke. That's what I wanted to say. It's my favorite joke. Right, so this one is rather interesting. So, all right. So we expect comma or separen, and okay. So, and then after that, we are expecting semicolons. So let me, Emacs, shut the fuck up, Emacs. Emacs, shut the fuck up. Okay, so expected that, but got that. Let's put a semicolon. Everything seems to be working. All right. So make asm a statement instead of primary expression. All right, and I'm going to push that right into the repo. All right, so that's pretty cool. That's pretty poggers, if I do say so myself. So we have some, for example, here. What the fuck is that? Excuse me. I spent so much time implementing a very cool macro called missingf. So, like, what it does, it tells you, like, it has a sort of like a predefined thing that this particular feature is not implemented, and then it gives you location within the source code of the compiler where you should go and implement it, and you do not use this macro. SMH my age. SMH my age. So let's actually see how it will work. For example, right, so I'm trying to build it, but I'm trying to build it for UXTN target. So what happens? Panicked, not yet implemented, and then points to the compiler. Okay, but where exactly in the source code I used an unimplemented feature? It's unclear. That's why I created a missingf macro. That's why I implemented a missingf macro. So let's actually see how you can use that. So you do missingf, and then you have to specify location. Luckily, we have location, I think, OP. Yeah, so you just specify OP log. We even use it in here. Look at that. We even use it in here. OP log. So inline assembly. Right. So look at that. Look now how it will look like. I forgot the new line. Right. So now it points at the source code, at the B source code in here, right? It points right here and then tells implementation should go here, and it points at the compiler. So there's two places. Here's where you try to use this feature, and here's where implementation should go. Very cool macro, isn't it? I think it's pretty cool. So the particular feature is missing, right? So here's the report. So you're trying to use this feature, it's not implemented, go here and implement it. Absolute shooting. So yeah, I really recommend to use this macro instead of to-doof. So sometimes it is not clear where to get the location, right? So because it very much depends on the location within the source code of B, right? Sometimes it is missing, but if you can get the location, I really recommend using missingf macro instead of to-do, because it gives like more context, right? So what exactly was tried to use and where you have to go. So it's much better. So cheers, by the way. Absolute shooting. Anyway, so let's actually do some stuff, right? So use, I'm gonna say something like to do missingf. Right, I'm gonna push that right into your repo, by the way. Right into your repo. All right. So I think I'm more or less happy with everything in this pull request except this test, because it is very much platform specific. It is very much platform specific. And how do I even test this kind of stuff on, for example, like ARM? So did you even add this test to, I don't think you added this test to Makefile because of that. right? So yeah, you didn't modify make files, right? So you were aware of the fact that it's not cross-platform. You just edited there, but you didn't run it. Okay, so I'll need to think how I'm gonna approach this entire stuff. So let me take a look at some of the subs. Thank you so much, Tona Kais, and thank you so much, Bridget Main, 41 with the message. Hello, is the RISC-V pull request going to get a dedicated stream? I'm really excited about it. Yes, it's going to get, we're going to have a dedicated stream for this kind of stuff, right? So I kind of want to revive it, right? So I rejected it at the time when I had different plans about accepting pull requests to this project, but now my plans have changed. Right. So yeah, this one is rather interesting. So ASM B. So maybe what I'm gonna do in here, because I'm not sure how we're gonna even approach this kind of stuff. So this test is too platform specific to be run on make test. So how should we approach dealing with such tests? Maybe on top of having a list of common tests, we should have the list of very platform specific tests. Yeah, because there are some things that are only testable on very specific targets. There should be something platform specific, right? So you can't have only tests that work everywhere. So some things may work only on very specific niche platforms. So, but I'm not sure how to approach that. So I'm going to just add it to do. I'm going to just add it to do in here. Right, so add to do to the ASM B test. All right, so I'm gonna push that right into the repo. All right, I think I'm happy with the state of this pull request, right? So, and I'm ready to merge it. I'm ready to merge it. So is it, doesn't have any conflicts? Okay, so that's cool. Looks good to me. Thank you for your contribution, right? And we are officially merging this entire thing. Absolute shooting. Anyways, moving on.